base graph that got shifted down -4. So 1, 2, 3, 4, first point, and it's a base graph, so there's no stretching. So it's a 0, 0, 1, 1 kind of setup, 2, 4, and I would highly suggest you do the 3, 9 because I don't know where it's going otherwise, right? So do 3, 9, 1, 2, 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that sound right? So there is my parabola. Yeah? Okay. So first off, what is my reciprocal graph going to be if I started off of f of x equals x squared minus 4? What would y equal for 1 over f of x? It would be 1 over x squared minus 4. It's not, too hard there, right? Okay, so again, this parabola is just your kind of starting points. The reciprocal graph does not include the parabola, right? We're going to have to erase it eventually or just make it like light. So I have the magic here of making mine very gray. So I'm going to make it like a light gray so you can hardly even see it, right? Okay. Huh? Okay. So all of these we're using starting spots to get to the end result, so just make them really light from now on. Okay. So same thing as yesterday. What will make undefined, or those vertical asymptotes? Wherever the height is 0. If I reciprocate 0, I get 1 over 0, and that is undefined. So where is that? Right here and right here. So what are we going to have there? A vertical asymptote going through 2 and -2. Does everybody see that? I'm supposed to state the equations of the vertical asymptote. So let's state it here. Vertical asymptote, x equals plus or minus 2. It has to be an equation, right? Okay, now we have to look for the 1s and -1s. Height. Where is it? Right there. And right there. Does everybody see on my graph where those heights of 1s are? They're at this height right here. So it intersects my gray graph at that height and that height here. Yes? Okay, now let's look for the -1 heights. Here's a -1 height. Where is it gray? Right there. And right there. It has to be the height where my graph is gray. So, height of 1, 2 spots. Height of -1, 2 spots. Okay? So, does everybody see, if you focus in on this from like basically greater than 2, it kind of looks like a line that's very steep, right? If you focus in right on that, it looks like a line. I'll even actually show you with this magic thing here, because I never got to do that. Yeah, let's see here. We got the magic pen. If I focus in, whoa, yeah. If I focus in, does everybody see? It kind of looks like a line going through that height of 1 there, yeah? So what I'm trying to say there is it's going to look very similar to yesterday's graphs. Where does the line go? It has a little, right? Okay, so technology. So same aspect. I have my invariant point right here. Bigger positives become smaller positives. And it's hard to even see that this is small positives there, but it's there. I'd have to focus in. You can see it's kind of going right there, yeah? If I reciprocate those really small things, what happens? Keeps on going, and it's going up. Yes? So I have asymptotic behavior going on there. Let's go to the other side. Again, if I focus in, does everybody see it kind of looks like a line right there? Yes? So we're going to have the same style of what's going on here. So 1 stays as 1. Bigger becomes smaller. So again, we're going to have that asymptotic behavior. And then right here where they're small, like you can actually see the small on this part of the graph, right? Smaller becomes bigger. So does everybody see what I got there so far? So I have the floops like that, right? Okay, now we have this third kind of section here. We don't know what's going on there, so let's look. Here's my negative ones. When I flip it, it becomes still -1, right? If I focus in right here, what do I have there? Small negatives. What do small negatives become when I flip it? Big negatives. So on this side, it's going to go going down. Same with over here. Do you see the small negatives? It's going to go coming down. Now, what's happening in the middle between those floops in that third section? Well, first off, do you think it's going to go all the way up here? No, because when you flip negatives, they're still negatives, right? Okay, so let's look at this point. What was this point here? -4 height. So what happens when you flip -4? It doesn't become positive, it becomes -1/4. So where's -1/4? Probably about there. I don't know, roughly. Yeah? 4, -4 becomes -1/4. Okay? So let's just pick another one just for fun. How about this height of -3? Everybody see there's 2 spots. That's where my 1s were. There was 2 spots where my height is -3. What does -3 become? -1/3, which is a little bit bigger negative than, so 3 becomes 1/3, say about there. So you see what's happening? It's just going to kind of curve around here. And even if you don't believe me, look at where the height is 2. Sorry, -2. I got to look over here. -2 becomes a half, right? But it's kind of hard to see. But that's what's going on here. It kind of loops back around. Okay, so you might say, well, how am I going to know what this is? Just remember, where it comes to a minimum here, that'll become a maximum there. So when I talk about, where's my horizontal asymptotes? It's at, yeah, y = 0. In this course, they're all going to be at y = 0. In grade 12, we'll have some shifts up and down. So, but you'll be able to see how it becomes, right? Because it's always going to, never going to cross the negatives if it's positive to begin with. And negatives are never going to cross into the positive. So it's always going to kind of settle around the 0, y = 0. Okay, what's my domain? I hear -infinity to +infinity. Is that true? No. There's a region that x cannot be. -infinity to -2. Thou shalt not pass. Yeah, then the u, and then we're going from -2 to 2. Thou shalt not pass. And we're going to go here to here, right? So how do we write that? With all these unions, right? Does it include -2? No, so it's going to be round brackets. Then round brackets from -2 to 2. Then round brackets from 2 to infinity. Okay, what about the range? Range. Start at the -infinity. Does it go all the way up to 0? No. What's the highest it gets to? -1/4. And then it kind of jumps, and where does it start again? 0, but it doesn't actually add 0, right? Then it goes to infinity. So -infinity to -1/4, does it include -1/4? Yes. Square brackets. Union. Then there's a jump. And where does it start off again? 0. Does it include 0? No, we never have a 0 there, right? So 0 to infinity. So this is huge right there. Yep. Okay. Yes. Right there, it is 0, comma, negative 1/4, right? This point right here. Okay. Like I said, once you do a couple of these, you'll see that a lot of the same things happen, right? Okay. Who remembers how to graph x squared plus x minus 6? Complete the square, sure. So I have y equals x squared plus x, leave a space, minus 6. So what is that? Half of the middle term is a half. Yes? Squared is a quarter. So because this, I just added a quarter to get that, what do I have to do to compensate? I have to minus a quarter. So what is negative a quarter minus 6? Negative 6 1/4. And you might say, well, no, you can't use mixed numbers. Well, you're not supposed to. But the reason I'm keeping it as negative 6 1/4 so I know exactly where the height is, okay? So really, we should be using negative 25/4. Does everybody understand that? Okay, but this, at least I know where the height is. So where's my vertex? Negative a half, negative 6 1/4. So say about there. Yes? And then we're going to do a 1, 1. And you might go, oh my gosh, how are you going to do this? Okay, so now at this point, you might say it's hard to do the pattern thing. However, I could solve for my x-intercepts because that's a huge thing, right? Knowing where my x-intercepts are. So how do I solve for my x-intercepts? I set y equal to 0 and solve. So 0 equals x squared plus x minus 6. So what is that? X plus 3x minus 2. So what's my x-intercept? Negative 3 and positive 2. So I know it has to be going through there and there. So let's take that vertex and make the shape of a parabola going like that. Does everybody see? Yes? Okay, so we got our parabola. Again, you're supposed to be doing this lightly so that we can gray it out. Okay, so I grayed it out. Okay, same technique. Where do we have vertical asymptotes? Where the height is 0. 2 spots where the height is 0. At 2, this is why it was good to find what my x-intercepts were. And negative 3. Everybody see that? So at this point, you know what those far kind of quadrants look like. What are they? Floop. Everybody see the floops? Okay, here's a height of 1. Watch the floop. You're getting a mark for shape. It doesn't have to be precise, except for those invariant points have to go through the right points. So here's a height of 1. It's kind of just right there. Bigger becomes small. On this side, it becomes smaller and bigger. So we have asymptote, asymptote. Okay? Any questions there? Okay, now we have that middle section we got to deal with. Find the invariant points. The invariant points are at height of negative 1. So there and there. Yes? What's going to happen? Okay, so what's going to happen? See, this parabola is getting little negatives there. So it's going to become big negatives, and then where is this minimum going to become a maximum? Well, what's that height right there? Negative 6 1/4. Remember, negative 6 1/4 was really negative 25/4. So we're going to flip negative 25/4, and what does that become? Yeah, negative 4/25. It's just not going to be 0, right? So as long as you have it in the right spot there. Say about there? Does everybody see why I'm not putting it on the y-axis? Because that vertex is a half over, right? So it should be, although mine doesn't look like it's halfway, but I'll try it. It's at a half right there, right? X is negative a half. My height is negative 4 over 25. And then I complete it going like this. Oh, I got to do that again. Sorry. It has to go through that invariant point in the right spot. So it's going to go like this. Ah. Try again. Ah. I can't get it. It's hard when it's that close, right? See, it looks like the same one as the last one, right? When do you think it's going to actually change? Yeah, if the parabola is above the x-axis, it's going to look slightly different, right? Okay, so what's the domain and range? Okay, first off, what's my vertical asymptotes? X equals what? 2 and x equals negative 3. What's my horizontal asymptote? Y equals 0. What is my domain? Negative infinity to negative 3, round bracket. Negative 3 to positive 2, union, 2 to infinity. Great. Range? I'm going from negative infinity. How high do I get up to? Yeah. So negative infinity to negative 4 over 25. Is that a round bracket or square bracket? Square. It includes that point. And then it starts up again at 0 to infinity. Beautiful. Okay, moving along. Okay, so what is this? It's a parabola again. How do we graph this parabola? It got stretched and moved. One where? To the right. Okay, so the normal parabola would be starting at 0, 0, it moved to the right. It didn't go up or down, it moved to the right. Then it's not a normal base parabola. It's not going 0, 0, 1, 1, 2, 4. It's going to go 0, 0. It got stretched now, so it's going to be 1 over 3. 1, 2, 3. And if it goes 2 over, instead of 2, 4, it's going to be 2, 12. So that's off the charts at that point. So we know it's just going to be really steep, right? So like this, if you want. It's really stretched. It's that stretched. Does everybody see? Yeah. Okay. Everybody good with that? Now I'm going to gray it out. Because remember, we're just starting with this. Either I'm going to erase it if I have pencil, or I'm going to make sure my answer is very noticeable. Okay. So where are we going to have a vertical asymptote? Where are we going to have a vertical asymptote? And here's 0 and 2. Try again. 1, that's where it's 0, right? Remember, the vertical asymptotes is where the height is 0. Where the height is 0 is the x-intercepts. Yes? Okay. Now, what's the next technique? Find your invariant points. Where's your invariant points? Right there and right there. You don't have any negative ones this time. You only have positive ones. It's very interesting. This is when math graphs get really cool because you get all these different things going on here. Okay, this is where you're going to take what I taught you to the next level. Small becomes large. Where is it small? Right here. Flip it, it becomes large. Yes? Large becomes small. You see that? And we have an asymptote. What's going to happen on the other side of the vertical asymptote? Anybody can tell? It's going to be the same thing, but it's going to be a reflection. So here it's small positive, so it becomes big positives. And big positives become small positives. Okay. So, what's my domain and range? What's my domain? Negative infinity to 1. Do I include 1? No. And then? Union. 1, 2, infinity. Okay. Range. Range. Do I include 0? Nope. 0 to infinity. Very good. Vertical asymptote. X equals 1. Horizontal asymptote. Y equals 0. Make sure you're making the equations though. Don't just say 1 and 0, right? Yeah? How do I graph f of x equals negative x squared minus 1? Huh? Start at negative 1. And it's opening down. Very good. So negative 1, and then you're going down 0, 0, 1, 1. Do you see that? 2, 4. 1, 2, 3, 4. That's probably good enough. That's all I need. And then I'm going to gray this out. I think you just... Before I actually graph this, can anybody predict what's going to happen here? Huh? How are we going to what? How are we going to get the graph? This is the coolest looking graph there ever was. Wait for it. Okay, first off, height of 0. Is there a height of 0? No. Which means I have no vertical asymptotes. Yeah. Second thing in our technique, find the 1s. Where's my 1s? I only have 1 at negative 1, right here. By 1s, I mean both positive 1 and negative 1, okay? It's plural. Okay, now what? I don't know. We know what to do here, people. Just try it. Okay, I'll give you a second, and if you're not willing to take it and actually write it, you don't want to ruin your page, take some scrap paper and try to see if you think you know what the shape is. It's like a pothole. So over here, because we're getting big negatives, it's going to be small negatives, and then it's going to go down and come back up. It's like a pothole. It shouldn't be more like that. It should be more like a loop, like a rounder, like that. I'm sure if you looked on the graphing calculator, it's kind of like, so if you were to have a graph that the parabola looks like that, what do you think is going to happen when you reciprocate it? Whatever that height is, it's going to be whatever that is, bigger, smaller, and then it's going to go like this. Speed bump. So if it's below turning down, it's going to be a reverse speed bump or a pothole. And that's the only kind of graph you'll end up getting, really. Okay, so we got to finish this off. So what is my domain and range? First off, I didn't put my horizontal asymptote, so I still have horizontal asymptotes at y equals 0. What's my domain? What? Domain is x's. Negative infinity to positive infinity. Very good. There's no vertical asymptote, so there's no undefined x's, right? Okay, what's my range? Negative 1, square brackets, right, because it includes it, to 0. Yeah. Round bracket. Yeah. Not very much. It's just a little loop, right? Because you have everything in your back pocket of how to do this, right? You start with where the height is 0, put a vertical asymptote. There was no vertical asymptote. Then you go to your 1s, find your invariant points, plot them. Small becomes big, big becomes small, you're done.